We are live. Welcome, Puneet. Welcome to the Engineering Unplugged podcast. Do you
Hey,
want to
man.
quickly introduce yourself?
Yeah. So my name is Puneet, and I've been working with Rippling for almost 6 years now. I started off as the head for automation team, and currently I work with the infrastructure team specifically around developer experience, developer productivity, things like that.
Awesome. Puneet, do you want to talk about a situation where you were challenged very, very deeply at a personal level and then you overcame that challenge?
At Rippling, my one of the common areas that I worked on was the CI/CD systems. Every day we had this situation where like somebody merges a PR and that pull request will run through all those tests and give a feedback. That feedback would automatically go and deploy the code. The problem here was that Rippling has a mono repo. It's got more than 20, 25 teams contributing the code to it. We ended up in a situation where there was some flaky test which would fail any time of the day. It could be during your 10 o'clock at night, could be at 3 a.m. in the morning, at very erratic hours. The test would fail, and we had no way of determining why they failed it. The teams would be present, the teams would be offline at that moment. So it became the onus of me, of the onus infra team, or rather me at that point, to go find that culprit PR, figure out whether it is safe to revert or not. Is there a quick fix that we can do to not revert the PR and move on? So this used to take a lot of my time. Every issue would take about 1 to 2 hours to go debug, triage, raise a fix, or skip if cannot be fixed, ping back to the contributing team and follow up with them. So there's an immediate 2 hour effort that goes into it, and
Yeah.
there's an aftermath of following up for another couple of hours to get that resolved. And this pattern was. This went on for a lot of months. It was very frustrating because I cannot sleep, I cannot take leaves, and this psychologically affects you a lot. This was a huge pain point that I had to struggle with. So what we ended up doing was after doing this for almost a year, when a new person joined the team, it's not possible for them to ramp up to the whole thing, all the product context, everything in a single day. So we started looking into how can you solve this problem in a way where I'm not the person triaging this. How do you decentralize this problem? So the very first thing was we need to have monitoring in place. We need to monitor what is the health of a test. So we started with defining what is the health of a test. Any test that is flaky for more than say 50% of the time is a bad test. And it could fail on your pull request. It could fail on master builds as well. The second thing we went about defining was how do you determine that a test is flaky? So just because you run it once, it would pass. Like whenever a developer writes a test, they would come and tell us, I ran this test locally. It is passing for me. This is this classic case where like it runs on my local but fails in production situation. So we started doing what the CI does. So in CI, if we run the test in a batch, like you have one say, so we run on Python. So one PyTest command would have a chain of 5-6 PyTest along with it. So we started giving some known patterns. Like if you run a test as a class, it would fail, but if you run it individually, it will succeed. So that was a known pattern. Then we defined another pattern that in case of Python, when you start a test, it could taint the context. Say, for example, there's an environment variable, you patch it in a previous test and you do not clear the patch, the tear down process, which is supposed to be done. You don't tear it down. The subsequent test is going to get the same context and then fail because the previous test caused that patch to happen. We found that as a pattern, and we would, as part of a signal from CI, whenever a test would fail, we would give them, okay, if you run these tests together, then this is definitely going to fail. So they now have a starting point. Instead of just running the test locally, they would go back and run the whole test with like those 2-3 tests together, and they would find, okay, this is the culprit test. This is where it is causing the issue. And the third thing which we did was we defined a routing mechanism. So until this point, we did not have we had module names, and the knowledge of which team owns which module was largely tribal. We don't have it written down somewhere. What we did was we built something called as a module mapper or a service catalog, in a way you can call it, which maps a particular module to a particular team. Now, a team is not a team unless it has an on-call, it has its own PagerDuty link, and it has its own Slack channel. We built a service catalog, and every team had to go and mention that, okay, we are the owners for this, we are the owners for this, and we filled that directory up. Once that is ready, and we obviously put a check saying that if you add a new directory, you have to fill this catalog. Otherwise, your CI build will fail. So once we have that model mapping in place, now whenever a model fails, we look up the service catalog, and the script is going to find out, okay, this is the test, this is the owner, this is the page editor, and we page them directly. And then now it is not on us anymore. They go and with the information on how to reduce flakiness, with the information on what test failed, that is enough for them to go and spend those 1 hour and get the thing resolved. So instead of me spending those 2 hours plus an extra 2 hours following up with them, it's now directly just they're doing it. Another thing which we did was, if you're a monolith, you're doing multiple different things. One of my senior managers told me that, why do you stress so much about a piece of code? So you need to always approach engineering problems with calmness. This was the best piece of advice I ever received with him. So I went back and I started taking the approach on, okay, these tests do not bring the system down. So we defined these are critical tests, and everything else beyond that is something that can fail for a few hours. It's not a problem. So what we did here was we built a mechanism where you tag the on-call, very good, but it could be possible that the person is sitting in Europe or the person is sitting in US and he's definitely having a good night's sleep. So if he responds to the on-call, well and good. But if he does not respond to the on-call, what do we do? Because other PRs are still going to have those test failures. So what we did here was we built a flaky test mechanism where if a test is not responded for almost an hour, it would raise an automatic PR saying, this test has been skipped. And, this is the reason. This is a Slack channel, Slack thread that you should look up to understand where did it first occur. And then obviously that information he can always refer back. Obviously, there's a backlash saying that, okay, my tests are skipped. But people started becoming owners of their tests, that seriousness about if the test is flaky, it should not be there. And if the test is stable, only then it should be. That cultural shift happened in the next 3 to 5 months in the company. And it's no longer my problem. I still get paged, but the frequency is very less. And the seriousness is very less. Like I just go and look whether it is an infrastructure issue or not, whether the instances are working fine, whether the Spot instances are living up, there's no outage around this, and the basic AWS level stuff is good. But yeah, anything beyond that is not my problem. The product team has to address it.
This was a very dense download of what happened and how did you fix it. Let's double click on some of it. There was a time when there was no routed alerts. In fact, there were no alerts at all, or maybe they were all coming to your team.
Yeah.
What was that situation like? Can you expand on to that?
Yeah. So the purpose of a test is to tell you whether your code is working fine or not before it hits production.
Of course.
And my team was responsible for CI system. So naturally, they assumed it was assumed that if a test fails, that's also my KPI.
Yeah.
Which was not correct because we didn't write the code. So what ended up happening was that we would get paged all across the day. We would be routing it manually to the product team. Every time this would happen, a lot of times teams would just be like, why is this test failing? This is not related to my code. And they would just force merge the PR. There were many cases where it would cause an incident, because even
a production incident,
yeah. A customer is facing that issue. And then we'll have to go and jump in and roll back the change. But, a deployment takes time, a rollback also takes time, and there's good 1.5 hour time. There was a point where we had about 2 to 3 incidents every day. And
wow.
This was very unmanageable, both for the CI team, for the product team. They're like, okay, we're writing code. We don't have trust on the system.
So why were the why were the alerts getting routed to your team? I assume you were the automation lead at this point.
Yeah. So my team was responsible for this whole, CI system. So we were responsible for the CI system as well as for test failures. So
which should not have been the case. Like in the hindsight,
the case. Yeah. We didn't have a mechanism to determine whom should we route this to. So we naturally became owners of the thing, and we would have a way of triaging it, finding which team to ping. And this was a lot of tribal knowledge. This was all internal document. We had an Excel sheet of who goes to who, and we had to keep when a new model is added, we have to go chase the team, update our sheet, and this is a fairly manual process.
Got it. So, and I assume in a growing company, like there are constantly new people getting added, new leads getting hired. So that sheet is also constantly changing and you wouldn't be able to keep up with it.
Yeah. people would change from team to team. So we would not know whether this person has changed to a different team. So now we are tagging him or her for a particular case, and they would come back and say, no, we have to switch team. You have to talk to this different person. So it was a pretty unmanageable situation at a point. Yeah.
Yeah, and up to a certain size of the company, it's probably possible to keep it in your head. But beyond, let's say, 100 or 150 people, you can't really keep track that who has moved to which team and who has gotten hired into which team.
Yeah, beyond 100, it is very hard.
So you didn't have the alert routing, and all of the alerts were coming to your team.
Correct. Yeah.
As a first step, did you add the routing, or did you try fixing some of the flakiness yourself, and the routing came much later?
The routing came, I think, much later. We didn't worry about routing until we had a new person join that particular team almost like a couple of years later. Until that point, since I had the product context, I thought I was the best person to do it. That was my mistake. Like, I thought I have the context. I didn't dump the context to a system. I just thought I have the context. Let me route it. Let me do it on my own. And I thought I would be the best person to quickly resolve it. So the thing was, I was trying to solve it quickly. I was not solving the problem. I was solving that one instance of the problem.
Okay. How would you personally solve some of these flaky situations?
We started determining, we took like 10, 15 different tests, and we started seeing on certain days why did they fail on a particular day? Why were they not failing when they were merged? The challenge was why they're not. And we found that people were making certain mistakes, like you run a test today and you put the assertion on a date, which is today. So if the date changes, the test is going to fail. And this is code written by very junior engineers, 2 years, 3 years experience. They're not like 10 years experience folks. So they put assertion on dates, and it works. It works pretty well for that particular day. And when you merge the PR, it's going to fail. Then we found cases where there were issues with weekends. Your logic works great on weekdays, but on weekends it will not work. So
it's an actual bug.
No, the product is supposed to work fine only on weekdays and not on weekends. So from a product point of view, it is correct, but the test says take the current date and perform the operation. If the current date is a holiday, the logic would short circuit and the test would fail.
Oh, so you have to freeze the time to a weekday date.
Yeah, something like that. They'll have to mock that behavior, patch that behavior where the test assumes it is a working day, and you have a separate test for a holiday. So you have both cases covered.
Got it.
They didn't have that. Another thing which we found out was we were making real network calls. Even if those network calls were failing, we were making those real network calls. An HTTP call will add extra overhead of, say, at least a 20 second, because you're making those interactions and you're you're waiting for the response to come back.
Yeah, there are multiple HTTP calls, not one.
Yeah, and imagine that going through thousands of tests. So the problem here was that these, first of all, you don't require these calls.
Like what?
So, for example, you're making a call to Google Maps to get address, completed address. You give one line address and it gives you the auto search.
You could have easily mocked it.
It can be easily mocked. Yeah. For us, because the key entry point, the Google API hasn't changed. Our source remains the same. The key string remains the same. So the response is always going to be the same. We don't want to test the part. We just want to take the response from Google and parse it. That's what it's supposed to do. So that was one case. Another case was, so Rippling does a lot of integration with third-party companies.
Right.
So we had some development tokens which were used to develop the feature, and they were accidentally also used to develop the test. And when the test token expires after 3 months, the test started failing. So this becomes a problem. So, and the third case, which is even more interesting, is the code is returned to work until a certain year. The code, say for example, you have a list of holidays. Just taking a random example, you have a list of holidays. You have the holidays defined till 2021, 2022, 2023. So when your code is running in 2021, it works fine. When the code is running in 2022, it works fine. But when the code runs in 2023 and you don't have the holiday list defined, the test would also fail and the code would also fail. Both are going to happen at the same time. So we came across, so to solve all these three problems, or rather detect them early on, we came with a system of, so for the network calls, we put a monitoring. Like every test, when it makes a network call, we pass the socket library. Whenever a network call is made, we have a dashboard which says, this test makes these many calls. At large, we can see which test takes makes most amount of calls. And with the service catalog, we go and tell the team that, okay, these are the tests which you could improve by patching the mock calls. And there are different libraries. Like we have, you can do a normal mock, or you can do something like a VCR cassette where you replay the API call every time rather than just making the real call. So we give them suggestions. This is one way you can solve the network call problem. For the case with time, what we did was we built a pipeline. It runs with a time frozen 1 week from now. So your tests are running, and this will not report directly to the master alerts, but this is running tests in future. And in that case, when a test fails, we'll go and tell you that, okay, this is going to fail after a week, or this is going to fail after like X number of days, and you have ample amount of time to go and fix it. If it fails on 1st January 2024, nobody's going to respond right away. But if you can tell them, a week in advance or 2 weeks in advance, they can put a charter on like who is going to work on it. No, it's not a panic state. It's
Correct.
a plan.
And you're predicting the failures, so they have enough time.
Yeah, we're predicting the failures. So this we did, and it worked wonders. We had about like 200 failures, which were prevented before the day happened. And so we even the cases of missing code, where like a condition which is required for the new year wasn't present, were caught. So with this running test in future, with mocking the network calls, measuring them, and telling teams how to mock those calls, those two workflows really helped with our flakiness. There have been weekends with 0 failures now. There have been a week, I think there were 5 days on a stretch with 0 alerts on master. And we were actually genuinely concerned whether our system is working or not, because we were so used or accustomed to the failures that when they don't come, you are like surprised. Okay, why are they not coming?
Right. So you mentioned some of the earlier cases, like a hard-coded date, or some piece that was hard-coded, like a hard-coded token.
Yeah.
When those things would fail at a later point in the future,
yeah,
would you be the one debugging it because alerts were coming to you?
Yeah. Without the service catalog, I was the one doing it.
How many developers were there in the org?
In the org as a whole?
Like the overall company.
Yeah, engineers. I think probably around 200, 250.
And how many people were in your team?
2.
So 2 people debugging the code that was written by 250 developers, and in various like business domains and product domains.
Yeah.
And you were looking at the code and trying to fix the tests.
Yeah.
How did you keep it up like for such a long time? I bet it was very stressful.
It was very stressful. And I initially thought that I should solve this problem. So I started looking from a developer perspective. I started looking at developer perspective that, if a test failure happens, what all information would they need to do? So I started building some process around it, like, between the last build and then this current build, which all commits were merged, look at each one of them and try to figure that out. I was always standing between, almost there, knowing how to do it correctly, but it was never a complete process. Like it was probably like, it gives you a 70% boost towards solving the problem, but it was never a 100% problem. And I always struggled with building it to the last 10% or 20% was always hard for me to figure out. Like it was always a manual process. So I would always assume that, unless I have the 95% thing done, the developers would not be able to do it on their own. I would always blame myself that, okay, I don't have a perfect system, so I cannot, emit it out to this common, to everybody yet. And hence I was never able to cross that line on, this is not me, but them.
So you tried building some tooling, but the code review was still manual at the end, where you had to narrow it down to, okay, this code is causing the problem. So why didn't it occur to you that this, had to be thrown back to the developers? You as a central team, with a 2/200 or 2/250 ratio, you cannot attack the debugging of why the test is failing. Why did it not occur? Like, why did you get stuck in to debugging it yourself for such a long time?
This is more about how I think the product development works here. As long as the product is functional, the test flakiness would not be treated with seriousness. even if I point out a test to the system, to the particular developer, it was difficult for me to convince them without a lot more process in place that, this is your fault. You have to go fix it. And we didn't have a way of preventing them. So even if I tell it to the developer that this is a flaky test, their first question would be, why was it not caught on a PR? And I didn't have a good answer to that. So without those strong answers, I would always find myself, end up, even if they fix it, how do they know for sure that this is actually fixed for good?
Okay, so basically you're saying that it was not escalating to a production incident yet. A flaky test was just a flaky test and not a production incident.
Correct.
And also the software ecosystem, the test ecosystem, etc., was very, very complex. And all of the nuances, you had somewhere an intuitive understanding of them, but it was difficult for you to explain it to people. What was the tipping point? Like, what made you decide that, oh, like this is too much, unhandleable, and we have to change things fundamentally? What was that tipping point?
I think the tipping point was when I was on a holiday, and then I was unreachable, and there was an entire day of master build failures, and an entire day builds were red. People were force merging PRs left, right, and center.
Why did people force merge PRs? Couldn't the features wait? Couldn't the PRs wait for a day?
If one test is failing and your code is coupled with a lot of other pieces of the code, that test failure was not relevant for you. And the product team's argument was that if the feature is working fine in production, the test is not really helping find an issue. So for them, they ignored the test because the test was not causing a problem. It was a flaky test.
Can you give an example?
A very simple case of an expired token. So the token has expired and it's making a real network call. So that API service is down. In that case,
but on which PR is this test failing? Is this an unrelated PR that doesn't even concern the integrations? There is this failing?
Yeah, this is an integration where we are using Google Maps API.
No, that I understood. So that's the test. Like
so this is a very common test. This is a missing mock for a very common test, which would run on every PR. This is like a generic feature we have. Like,
okay, so even if you had some unrelated feature PR, this test is going to fail there, and it's unrelated. So
almost 70% of the PRs would run them. We had that 60 to 70% of the PRs would run them, and 30% of the PRs for them they will not run. So yeah, we don't run all tests on PRs. Let me just clarify that piece. We don't run all tests on all PRs. We have a way to figure out, based on the dependency graph, this model imports these models. So if a change is made to this particular model, only the test for that particular model or the associated models would run. But if there is a common test which is touching more surface area, so another argument from developers was that it works on 7 days a week. Why does it 5 days a week? Why does it fail only on 3 days or for?
And the onus was then on you because it was your responsibility to maintain the green status of the CI.
Yeah, I am responsible for the CI health. So
the onus was on you to figure it out. Okay, this is why it is failing. You have hard-coded the day, or you are actually not freezing the time, and the test is only supposed to run on weekdays or working days.
Correct. Yeah.
Okay, so there was a point when you realized that, oh, this is not going to sustain, but it was not causing production failures yet.
Yeah.
But it was causing a lot of personal inconvenience. What was then on the reaction?
Beyond personal inconvenience, even it was also an inconvenience for developers as well, because if your PR has minimum amount of reviews, required amount of reviews, and the CI gives you a green check, they can merge the PRs on their own. Otherwise, they'll have to look for their managers, because only managers can force merge. Developers cannot. There are only 5 or maybe 10 people who could force merge PRs out of those 250 people.
Okay.
So you have to find one of those 10 people to
and then explain why it has to be force merged.
Yeah. So there was a friction for them. And there's a lot of unrest among developers as well. There were always things like, why is the system so flaky? They would not ask the question that why is the test flaky? They would ask, why is the system flaky? Because like I said, if you run the method locally, it would pass. So they'd be like, okay, the test is working fine for me when I wrote it. It's working fine for me right now. Why is it failing in master?
When you discover that there is a flaky test and somebody figures out, you are a developer, that this is the reason, right? They would fix it. But then they would have to run the CI suite to actually get the confirmation that, yes, this has gotten fixed.
Yeah.
Were there any hurdles on that portion? Like, was it fast enough for them to verify that my fix is actually fixing the flakiness? How would that process go?
It wasn't very unless we did until we didn't have those pipelines where you run a test in future. See, suppose the test failed on a Saturday. We flagged it on a Saturday. They try to run the test on a Monday and it would work fine because the test is only going to fail on Saturday, Sundays. And I haven't figured out that it is because of a weekend situation. They haven't figured it out because of the weekend situation. So they would be just saying, okay, the test is working fine. It's not flaky. And they'll just go back and merge it. So there were cases where they would, fix it and then it would fail again next week. So until this happened for a couple of weeks where we realized, okay, probably there's some code logic due to which it's running only on a weekend, or maybe it's failing because there's a difference between PST and IST hours. Like your test is supposed to take UTC time as reference, but it is running PST time as reference. There's a 5-hour gap between the time zone switch. So the test is going to fail on a Sunday morning, and people would be like, okay, they come back on Monday, the test is not failing anymore.
Yeah.
So they would deprioritize it.
Was there another ingredient to it? Like, was it too hard for them to run the full suite? Was it taking a long time?
We have about, I would say, more than 50,000 tests. They are largely functional tests. The unit test coverage, like we have 20% of unit tests and about 80% of functional tests. And the setup is heavy. The test alone takes about 30 seconds for a startup. And then, the actual method would do some sort of, setup. Then it's going to perform the actual test operation. So if you have to run the entire code base to, test suite for the entire code base locally, they cannot do that. And since we didn't have processes like, running a test in future or measuring the network calls, they did not know what's the cause of slowness. They didn't know what is the cause of the flakiness in a way. So it was them. If the author of the code is looking at that piece of code, they would know that, okay, this is because of a condition. But otherwise, even the developers would have to spend 3 to 4 hours trying to figure out why this is happening.
Got it. So the cycle times were also very large because they will have to commit and then the CI would run it for them. And how long a typical CI run would take? So once they commit, when would they know whether it has passed or not? Would it be in a few minutes, in a few hours, or like how
would it be? Around 25 to 30 minutes.
30 minutes. So, okay. So in a 4-hour window, you could do just 8 attempts at best to see if, this is fixing it or that is fixing it. So if you didn't know the cause, it was a very painful process to narrow it down.
Yeah, or you could do just parallel PRs. But yeah, again, it's maybe you can increase it to 12 or 14.
Who does that?
Yeah.
Yeah. So didn't people say that this needs to be faster? Did you invest in speeding up the CI suite in any way?
This became a problem. So we have actually, this is the third, our CI system has changed across the years. Mm-hmm. We started with say Circle CI. We started with Circle CI. We then moved on to Jenkins.
Self-hosted?
Yeah, Jenkins was self-hosted. Yeah. And then we moved from Jenkins. In Jenkins, the problem was with scale. So we moved from Jenkins to Buildkite right now. And so from the reason for migration from Circle CI to Jenkins was cost, because Circle CI was just expensive and we did not have control on the instances. On Jenkins, since it's all self-hosted, we could decide what instance size we want, and we can increase the parallelism. So we can run more parallel tests, we can just throw more like resource at the problem. But while you were at Jenkins, one problem that we realized was our product was very Mongo dependent. So
MongoDB
dependent, yeah.
Okay.
So if you run a test, it's going to insert some collections and then read from them, and that read-write process we felt was slowing down the test. And we made attempts to mark certain collection calls. We made attempts to reduce the number of data being seeded before you run the test. But there's only a limit to which you can do all of this. So then we came across an idea of how do you make Mongo faster. We started looking into that. And one of the easiest ways we could come up with was, so Mongo by default says you can run it on Wild Tiger storage engine. But they also have a different storage engine, which is in memory. So instead of writing the collection to disk, now it is writing the collections to RAM. And RAM writes are faster. But in-memory is not a community feature. It's an enterprise feature. So the other workaround which we found was you could create a Docker Mongo container, which is using TempFS as your disk. So it's still using RAM, but just not the Mongo's version of RAM, approach of using RAM rather than the Wired Tiger on a TempFS disk. And
Yeah, so
that,
Mongo still thinks it's a disk,
yeah,
but your disk is a TempFS.
actually, yeah,
RAM.
it's a RAM. Yeah.
Okay,
So that actually worked wonders for us. It
neat.
reduced our test execution time by about 30-35% flat. So this also allowed us to run more parallel tests in the same instance on Jenkins, and it helped us. Like we had a flat 25 to 30% drop in cost as well.
Okay, so TempFS in Mongo was one speed up. Were there any other speed ups that you guys discovered, like parallelization, probably?
Parallelization, I think, was very straightforward. We just we had a round robin system, and we measured every test execution time, and we used that to do an effective bin packing of which test should run which test, so that the parallelization became at its best. Like it's very compact. So a long test would a long running test, a test that takes more than say 10 minutes, that runs on the top, but a lot of these 20-second tests are bunched together at the bottom. So that bin packing helped with the parallelization helped us making the slowest test the bottleneck. And then we would go back and tell teams that your test is causing the slowness, your test is causing the bottleneck for the whole CI build to slow down.
So it was a weighted sort of bin packing.
Weighted distribution, yes, it was a very weighted average distribution.
How was this running? Like this was running on Circle CI or Jenkins, or
This
how?
was on Jenkins. This was on Jenkins. We didn't do this on Circle CI. Circle CI was very elementary bin packing, but our scale was very low. We moved to Jenkins very early on, maybe in 2020, 2019.
Sounds good. So how long does the CI suite take today?
Today it takes about 45 minutes with I think 3x or 4x the amount of tests that we had when we were running it 3 years ago. So the test coverage has increased, but the time hasn't. Time is still floating in the 35 to 45-minute range. And on PRs, it is 25 minutes. So
because you run reduced tests.
Yeah, I think I'll just put a note on the flakiness, on the slowness part.
Yeah.
The master builds run every test. So that would give you a flat 45-minute build. But on the PRs, it used to take 40 minutes, running 40 minutes even on PRs. And the challenge here was people were curious that, okay, my code is only touching, say, a billing module or a payroll module. Why is it running so many tests? And the reason was coupling. Our code is very deeply coupled. And like you write one utility in one random place, and then you use the utility across all modules. So we built this dependency graph of how imports are scattered across code base. And we realized that, okay, these 10 culprits, if you just decouple them, your dependency graph reduces in such a manner that only 30% of the PRs need to run those 40-minute tests. And the others could just run their own module suits and 20-25-minute thing. And that did wonders. Like we made a list of 20 such coupled modules or tests, rather, I would say. And once we fixed that dependency situation, and a lot of them were unused imports, by the way. They just copied files from one test to another test, and they just used it without removing them. And so this unused imports and these coupled imports, once we fixed them, we ended up with a very decoupled code where only 30% of the PRs were running 40-45 minutes. Every other PR was running in 25 minutes. So the feedback was much faster now.
So tell me something. This would also go back to like code organization as to where people are, not just the test code, but the actual logic, how it is organized in files. And if people are dumping everything in one file, I assume the dependencies would be at the module level, so at the file level, as to which file depends on the other. So did you like improve the code organization as well?
So there are two types of code in the code base. There's the test code and there's the application code. Now, the coupling in application code is quickly visible on production because the app startup would slow down. There'll be circular dependencies. So things like that, they actually show up in runtime errors. So the production coupling was very quickly visible, but the test coupling was not very visible because it runs on a different system altogether, which is monitored by my team and not by developers usually.
Right.
So on the test coupling side, we had to put some effort. When you write an application code, you don't just dump in every import that you have. You make some effort, and they usually come up in PR reviews. But the test code does not run in production in the application directly, so they don't bother much about it. But, so that came to us, and we had to go and investigate the coupling piece. It wasn't a problem in the product code.
So the unused imports, right? Wouldn't that be caught by something like a linter?
Yeah, so that was the next thing that we actually started looking at. To solve this unused import problem, we did not definitely go through manually each file. that would have been a disaster, because you have more than, say, 20,000, 30,000 files. And we definitely did not go into doing
And you have
that.
learned your lesson by
Yeah,
not trying to fix it yourself.
Yes. With the test, we did learn that. So then we invested some time into static analysis tools. And this is where I think three things come into picture. One is linters, formatters, and type checks. So I'll first talk about linters a bit. We used PyLint, we used Black, we used I think ISORT and a few others.
Mm-hmm.
And what we started doing here was it would automatically determine. So in tests, there is very less risk of removing code and not breaking stuff. So this is, I think, a Python peeve that I have is a Python code could import from one module something, not use it there, and then another file is going to import it and use it.
Oh, yeah. It gets redeclared when you import it.
Yeah, exactly. It gets redeclared. So this is a indirect import situation where you're unnecessarily making the middle file or the middleman, the file as a middleman in the whole import process, and unnecessary coupling is happening. So first you determine your indirect imports, and then you kill them. And indirect imports are caused, at least for the 70% of the time, caused by wildcard imports. So you take a module, you import everything from that module. So everything gets redeclared and forwarded to the other module. So something like a date time is being imported from, say, a common modules library, where it should be imported from datetime library itself.
Yeah, directly. Yeah.
So there's wildcard imports, there's indirect imports, and then there are unused imports. So first,
so now that common thing becomes a dependency for this
everyone.
file.
Yeah. So we started with we started using Pants as a build system. Pants is the tool that we use to put analysis on the code. So Pants is a very nice build tool, much like Bazel that people have for Java, where it analyzes your code and gives you the ability to put additional checks. So first we did checks on wildcard imports. So first of all, you cannot do import star anywhere. And we wrote some custom scripts to clean up the existing code base on how the import should be done. Once we got rid of the wildcard imports, and we had a check which prevents, you can't do any more new wildcard imports. Second thing we did was we reduced these, we first measured the indirect imports, and we cut down. So for the common modules, it was very straightforward. Like what you import from the
import date time from date time, for example.
Yeah, so those basic ones are very easy. We were able to, because we know this is a known list. For the code ones, it took we figured out a graph situation where, like, these are the modules they are supposed to be imported from. We generated that data that, okay, these are the modules they should be separated from, and if they're not imported from that particular module, you end up throwing an exception.
So you would do AST parsing of the code to figure out.
We did the AST parsing of the code to figure that out.
Okay.
Then we figured out fixed the indirect import situation. And the third thing which we did finally was unused imports. So once for unused imports, we can directly use Black and ISORT. They directly go and just remove the unused imports for you, and we don't have to do any extra coding to do this. Like, this is out of the box. This and Autoflake. These three libraries, we have it currently enforced in our code base, where any new code that goes into our CI system or even locally, we will use these linters to format your code, to lint your code, and remove these right at the get-go. So whenever now somebody gets a new file, they are subject to these checks, and this does not even get to master, preventing a lot of this coupling, preventing a lot of these headaches where people are like, okay, why is my test slow? Why is the startup slow? Why is this going down? Because they're no longer happening. We just don't let them happen.
What was the time investment to introduce these tools?
It took us about 2 to 3 quarters.
Because the
This
code base was that large, and I think
the
the
code base
team
was a
was also
large,
that large.
and yeah, you cannot just enforce things because. So one thing you have to understand about rippling is we raise about 200 PRs every day. About 100 PRs get merged. So this is
About one PR average per person per day,
yeah
which seems like the right pace.
yeah yeah yeah.
Yeah.
Yeah. So this is a high, since this is a monolith, there's so many code being merged from all across. So if you suppose wake up in the morning and you decide that I want to enforce lint on 500 lines, 500 files, or like 1,000 files or 2,000 files, you are expect to be hit by conflicts. The PRs that have been raised, if they're not rebased with master periodically, they'll see a lot of conflicts. So we realize that you can't do it you have to do it in a systematic manner. First, you prevent newcomers, then you start systematically going module by module or by team, and then get their buy-in on formatting their code. Initial, I think first 2 quarters we just made it opt-in because we were introducing a new tool, and we didn't have the bandwidth to be always on top of things.
Right.
So it was just opt-in where like teams find it valuable. We did work with one or two teams and sat together and raised the PRs and did it for them. For other teams, we just said them,
Adopt.
opt-
Like, please adopt whenever you
yeah, please adopt.
think it's the right time for you.
Yeah, and the adoption took us few quarters there, but after 3 quarters, we were like, okay, autoflick is enforced. This is enforced, and this I'm talking about production system. For tests, we were very aggressive. For tests, we rolled out in like 2 months, everything in 2 months. For production code, we did a little more of opt-in. Like if you don't like these checks, you can opt out, go do it at a later point. But for tests, certain checks were really mandatory. Like autoflick is mandatory, isort is mandatory, because the risk of things failing in CI is still manageable.
Yeah.
But you can't have errors happen in production because you missed an import.
Right. So the cultural change was, I think, the hard part here, because the teams are also moving with a lot of speed, and you are essentially increasing their work that they have to do before they can merge their PR.
Yeah.
Did you face a pushback? Like, were teams open to it, or were they apprehensive? And how was that like?
I would just probably point in one case from front end, then arrive at the actual point. So front end also has these formatters. They also have these linters in place.
Yeah.
But the linters would run on a pre-commit hook because they were very fast. They would run in like 10 seconds or 5 seconds. So a commit hook or a pre-push hook was not that expensive for developers. But for us, for the backend side, the parents build system would take easily 30 to 40 seconds. So, your commit process is hung up for that long time. So you can't make a pre-commit hook yet because of the time that it takes to make a commit.
Okay.
And on CI, we initially thought we would just fail the build. But people would be like, okay, I pushed my commit. It takes so much time to run the test. The feedback is not in a minute. The feedback is in like 20 minutes, 30 minutes. So they started complaining that, my builds are failing. And this for a lint error, which I could have done locally.
Yeah.
So what we started doing was that we started linting the PRs itself, that we push an extra commit and lint the code for you. So then the problem was that, when you try to push your new commit, it will say, there's already an existing commit. You have to pull and then you have to push again. This breaks their workflow. Ideally, I want to commit and push. You don't want to pull from a random bot. You don't want to push a bot commit. That just and you also don't know what changes it has made. You have to look at the commit manually to see what all changes it has made. So initially, a lot of teams were apprehensive, like, we don't want that. So we decided to distinguish, have a boundary between these are required because they really, really are critical. And some are like just good to have. So for example, isort was good to have. Sorting the imports really do not make any difference. They just look good. So we made sorting optional. We made black formatting also optional because single quotes, double quotes, and things like
single line, empty line versus double empty line.
Those are like not really helping you around much. But imports, extra imports, they were. So autoflick was made mandatory. Since we have already solved the wildcard import problem, and the indirect import problem, bringing about the autoflick was much easier. And that had a lot of impact. So we got buy-ins from the managers, and the managers would push down the teams to get those things done, get those things mandatory, and stick to them. And I think those are fine with people. People are okay with those imports, those changes. But since this happens very less, you only when you're working on a existing file, you import less. You don't copy a lot of changes. So
usually you write new code, but
yeah.
imports are not introduced as frequently.
Yeah. So the additional commit, that the bot generated commit were rare. They would probably happen once in a week for the dev developer. It wasn't that frequent. So I think so that's the reason why we went with opt-in, because a lot of developers were like, we don't need them. Why are we needing them? What is the value add?
So you balanced it basically, rather than removing it completely versus introducing it completely. You removed the unnecessary parts and kept the necessary ones, thereby making it easier, and it was easier for adoption. And you could have easily added more weight to these auto-generated commits later when the adoption was good.
One last thing that I would just to complement to this. So the ideal workflow would be to do these checks pre-commit.
Yes.
And so we actually went back to the pants team and we asked them, like, this is slow. What can we do to make this faster? And we were actually part of their beta programs often. We actually work with them closely to improve the pants build system. And we reached a point where, like, the tool itself was faster, installation of the tool was faster. And I think that there's another tool which we discovered along the process, Rough, which is based on Rust. So it does the same job, but in 2 seconds. So our idea,
Rust.
Because it's running on Rust. Scanning the files is much faster in Rust. Python does it much slower. So we found an alternative. Wow. And it's the same thing. And our goal was to do it in 2 seconds. Rough does it in 2 for the entire code base. I'm not talking about changed files. I'm talking about the entire code base in 2 to 3 seconds. So this is our golden boy. Let's adopt this. And now we are at the state where, like, probably in a couple of weeks from now, or maybe a month from now at best, we would be able to introduce a pre-commit with these lints locally done.
So this is still in progress. You are still building this with Rough.
Yeah, we have the pilot done. We have done it. We have a beta group where this is rolled out, and probably in another month, once we look at the stability numbers, we'll roll it out to everyone.
So let's talk about the cultural aspect of it. See, people are busy committing, to so many PRs, and they want to move fast with the feature building. And you're giving them more work to be done before their PRs can be merged. There would have been a cultural pushback. And I think the key point that I picked up from your description was that you did it incrementally. You didn't impose it onto them. It was done incrementally, and you worked with teams. There was a beta program, and you handholded teams to do this comfortably. But there is a crucial point that I want to expand upon, which is a transfer of ownership. Earlier, you were the owner to fixing tests. Now, through these changes, the teams and the developers will themselves be the owner for fixing tests. How did this transfer of ownership go? Did it see a lot of pushback, and did people receive it peacefully, or did you have to push? And how did that whole process go?
So, very good question. What I want to talk about here is that every time you introduce something new, like you said, it's additional work for the developer.
Yeah.
We started with having a simple documentation. That additional work, if we can minimize for them, we don't want them to learn what black is. We don't want them to learn what Flaky is. We don't want them to learn what freeze gun is. We want them to learn patterns.
To make the learning curve more easy for them.
Yeah. So we went ahead and wrote documentation, and every documentation would have top 5 examples, which they see most common. So if you look up the documentation, you spend like 5 minutes and you would know what to do. Okay. Initially, it was very complicated because we have to, consume all the information and dump it down for them.
Yeah.
Once you make the learning curve very limited, like everybody's willing to spare 5 minutes. Everybody is willing to spend those 5 minutes because their CI build is still running. They can't do much there. Yeah. So they would spend those 5 minutes, learn what the tool is about, why it is important, what's the impact, why should they do it. if they don't understand the impact, what's the value add? I think there's no value for us to introduce a tool if there's no value add. So, for example, one thing which we did along with in the static analysis part was introducing type checks. Now, Python makes life easier for people. They can
Okay.
just write code and then run things.
Yeah.
But type check is something which is forcing you back to think about how you're writing code. Whether you're returning none, whether returning in a string, or whether you're returning an object, what kind of object you're returning, all of those things. So people were very averse to like, why do we need type checks? The code has been running so fine so far for all those years.
Right.
So we had to pick up certain runtime errors. We put them back in our documentation saying these runtime errors were caught by this type check declarations and failures detections. Again, this was also opt-in. So to summarize, I would say document in a way where developers can understand. Give them a TLDR. Give them a 5-minute summary.
Yeah.
Then go into explaining the details, because in those 5 minutes you have sold the idea of this being important, this being making their life easy.
Yeah. So you quantified the impact for them.
Yes, we quantified the impact. We give them we give the value add proposition. We give them why this is important for you, instead of why it is important for the company or for me. I think
Right.
initially they thought that the CI team wants it. That narrative has to be changed. For a long months, they thought the CI team wants it like this, but eventually we made them believe that it is you who wants this, and this is going to make your life easier, because the code commit till production and then back, that whole cycle could take you days, but a type check is going to catch you right away, and your code could be imported by somebody else. Without type check, your code could be used in any manner, but the type check failure would tell you that, okay, they are not providing the right arguments in certain method, and that would fail it for them on the PR itself. So instant feedback, or like close to quicker feedback, rather, I would say.
See, so this made the adoption easy. I get that. But how did the responsibility get shifted? The CI team could still very well be responsible. That if when the CI fails, it's the central team who will look at it, and developers can do all of this goodies, and they can adopt the linting, etc. But how did the transfer of responsibility as to when the tests fail, it is your test, so your responsibility. How did that shift go?
I think for this, I would say a lot of this is was brought down from the CTO or the engineering heads.
Okay, so it had to be enforced like top down.
Yeah, it was enforced top down, because it's now a matter of the module or the team's product quality. The product quality improves with better tests. Like the metrics for a team's performance was less incidents, the operation time, the performance, and there were like 10 different metrics. One of the metrics was the flakiness of their tests. That was brought in as part of the team's metrics. And, since we have a way to determine which team this test belong to, what's the percent of flakiness, it impacts the test team's health. And like then the management of the leadership, they were like, okay, you need to fix this, and this was brought in top down.
How difficult was this quantification? I mean, you would have to build tools. I guess it's not that difficult to measure the flakiness, etc.
Yeah, I think tools were very straightforward. We didn't have to put a lot of effort. I think wherever tools were not present, we just used AST parsing and got the data out. But otherwise, we just assumed a few things. Like, for example, if you're writing a code in a particular module, you own it. So a team module ownership was clearly defined. We didn't go into that, okay, this method is owned by that particular team. If that is happening, then you're writing the code badly. You have to move your modules.
Yeah, then refactor.
Yeah,
that's your problem.
Yeah, we didn't go into that depth. We just went like, okay, module to this mapping, and then modules stats becomes your team stats. It was very straightforward in that manner.
And is this like, have you rerouted the alerts to the teams yet, or are the alerts still coming to you?
They're already done. They've been done for almost 6 months now, more than 6 months now.
What was the response like when the alert started going to the teams? Would they attend to it? Was the urgency there, or did you have to? I mean, one thing is to route the alerts, but second thing is to actually create the urgency on the ground and change that behavior. How was that?
When we did the routing, we also brought in the test skipping mechanism. Where like, if you do not acknowledge your alert for 30 minutes or like an hour, initially it was. So if you don't respond for an hour, we'll just skip the test, because you don't care about it. why should we care about it? I think we start with that aggressive mindset.
Only if the test was not critical.
Exactly. You don't care about it because if there are critical workflows in the system for which they're paged as soon as they fail. Like for example, if somebody's tax, if a tax document did not get sent to the particular bank, you would get paged right away, and you have to wake up wherever you are, or like you will have an on call. I wouldn't say wake up, but you have an on call to handle it at all times of the day. There's a good 3% rotation. So if that is critical, you have an alert system in place. If your tests are not critical, we are good to skip them, right? And this was definitely met with a backlash. People were like,
no. So tell me something. I wonder how would that critical test end up failing? Like, is this failure in a feature branch or in the master branch?
No. So this is not a critical test. For critical tests, we have a whitelist. They're like
these cannot fail. Like these are the
fail. These cannot be skipped. It's more like these can fail, but these cannot be skipped. So in that case, it was on the DevX team, on the infra team rather, to go and look them up and figure out, find the team, do the trash. So those 10, 15 tests we still have the ownership on because they are super critical and we cannot afford to skip them. We cannot skip them.
When these golden tests fail, those would fail in the feature branch or in the master branch?
They would fail in the master branch.
How would that happen? Because of flakiness.
Take a case where we define the import dependency. We find we have a way to determine that this particular test requires this model. Now, if somebody goes and bypasses that by doing something like an import lib and passing a string as an import, so that test did not run on the CI build, on the PR's CI build.
Oh.
And then it would get merged.
Because the import is happening at runtime, the AST parsing wouldn't figure it out.
Exactly.
And you wouldn't run because you're running the partial set of tests on the PR.
Yes.
I see. Okay. Simple enough scenario.
Yeah.
Got it.
But the frequency of such issues was very, very low, like maybe once in a month. So for us, it was still manageable.
And eventually you would like burn them down.
And and we would go back and figure out ways to address them. And we had we would say, don't do this pattern. We put explicit pattern checks using static analysis again. We have some grep which says, don't do these patterns. So on the PR itself, the automation is going to tell you that, okay, this is a bad pattern, don't do it. And requires a manual approval of sorts.
Okay. Sounds good. So this is the critical test, like the golden tests, which are failing, and the central team is still responsible for it, and you will follow up with people and you'll create urgency around it. How about the non-critical tests? The alert would go to them. Did you have to do something extra to change the behavior where the urgency was correctly understood by the teams? Because it's very easy to ignore an alert, right?
Yeah. So what we did was the first alert would go, okay, and suppose the on-call, whoever it is, they're going to, assuming they do not acknowledge it. So what happens is that after 1 hour, the test would get skipped. And 1 day later, we would, on the same thread, if we have not seen any, so if the test is still skipped state, we have the data. So on the same thread, the on-call would be tagged again saying, what's the status of it? So, and there's a third follow-up. There are like 2 follow-ups that we have on the same Slack thread. The third follow-up, we'll tag the manager as well. So in this manner, even if the developer skips it, the manager is going to be tagged and they would go and follow up with the team. Okay, why is this skipped and why is this not?
Okay, so you would escalate it if you don't see a response, and then eventually managers would drive it. Yeah. And again, in that sense, it was driven top.
And this is based by the bot. So we have the automation bot which does this. We don't go manually do this.
Right.
It's all automated.
Because the manager is driving the change top down, eventually the team would understand that, yeah, there's something they need to do.
Yeah.
So now what is the state of affairs? Like, do the alerts go to these specific teams automatically and do they respond to it? So what's the central team's involvement? Have you democratized it completely? Or does some of it still come back to you?
We only manage the infrastructure issues. That's it. The failures for the master build failures, they don't come to us. We only look for, we do get alerted on the Slack, and we just look at whether it is an infrastructure problem or not. Most often it is not. And later on, what we did was that this I'm talking about in the last 1 month. So we also have a process to determine that this is actually an infra failure. So if we get an alert for an infra failure as well as a master build failure, we know it is infra failure. If we do not get an alert for an infra failure, we just don't worry about it.
So in case of the infra failure, you have your separate set of alerts, but the master build would fail and that alert would go to the teams. You would not
Yes.
prevent that alert from going.
Yes.
Got it. And how did you differentiate between the infra failures versus the application code failing, like the test failing?
We have different error codes defined. So we have since the process is defined into multiple stages. So every first, say, 10 stages are owned by infra, and post that, the issues are all the other stages are owned by non-infra. And
You mean stages of the Jenkins pipeline?
Yeah, the test stages, the stages where the tests are run. So any stage above it is owned by infra. From that stage onward, where the tests are started up, that is owned by the product. So if any failure happens in those stages, it's definitely a product issue.
Okay.
And we also have a secondary signal where, like, we have a monitor on the instance. So whenever a stage, when it fails, it exits, it will try to pull out the failure message. So if a test failure happens, we usually have an exit code as 1. But if an infra failure happens, be it, say, there's a time issue, there is like some AWS plugin issue with that, the AWS instance, we would get a non-zero, non-1 exit code. And for that exit code, we have 2 action items. One is like, if we can kill the instance, we just kill the instance and rerun the stage, or we go back and just alert the infra team where things are not manually possible, like automatically possible.
And somebody would look at it.
Yeah, somebody would look at it.
Let me take an example. So let's say the tests have started running, and somebody just dumps a lot of data in the database, which is seemingly the disk, but in the test case, it's not, and it's in-memory temp-fs, and you run out of the space because the RAM is limited. So you run out of space, and you get that exception. Is this considered an infra failure or a test failure? And how do you categorize this automatically today?
Yeah. So there's an out of memory issue, and the instance would go down right away. And the build kit scaffolding would give us a non-zero, non-1 exception. And from that status code, we'll get an alert through Datadog, and we'll go and investigate it.
For whom? For infra team?
For infra team, yeah.
Okay, so this considered an infra alert because it's out of memory and the instance went down.
Yeah.
And then only you, after manually debugging it, you would realize that, oh, like this is the new test and it's doing dumping a lot of the data on the disk.
Yeah.
I see. Got it. So it's not fully automated, but it's automated enough to the point that your life is manageable.
Yeah. Once we find a pattern or a recipe, we include the new recipe.
So you keep improving the automation.
Yeah, it's pluggable. So you keep adding more recipes, and for every recipe, we have an exit code, we have a way to handle it. We have a way to exit code, we have a way to handle it.
So over the time, the system's automatic detection becomes more intelligent.
Yeah. And also now we have a much larger team. We have like a 4-member team, 5-member team, specifically only on CI.
So there is a lot more coding, a lot more maturity in the system that you can bring. A slightly different question, Puneet. Yeah. If you had to, now from all of these learnings, if you had to give an advice to your past self, if you could go back in time and tell yourself, don't do these mistakes, right? By extension, you're telling our viewers that you can avoid these mistakes. What would they be?
I think the very first thing is don't go for instant gratification. It feels good to you get that dopamine effect where 3 builds are failing, and then you go and fix it, and you see that green build, and it excites you, like, okay, I fixed something, you achieved something. No, you're not achieved something. It's you have not really solved the problem. You have solved an instance of a problem. So have postmortems. Whenever something like this happens, where you are not the owner of fixing a problem, do a postmortem, and through postmortems, what happens is you bring in more people to help you solve the problem. Because when you do a postmortem, you highlight the problem, you highlight a fix that you think of is correct. You are basically not the DRI anymore. You are never the DRI, but since you started fixing it and you started thinking, okay, your job is done here. You take away that instrument, but you should not do that. You should basically, since it is not your thing, build a system, build a framework, and solve it in that manner. This
Okay.
gives you a lot of peace of mind, knowing that the framework exists. And
Okay.
frameworks are easier to explain to other people. So more people can be onboarded to a framework.
And they can extend it as well. They can improve it to suit their own needs. Okay. So solve the pattern, don't solve the instance.
Yeah.
What else? What would you tell your past self?
Always read. I think one thing which we did as part of all of these,
Always what?
always keep reading about articles and things which are relevant to your stream. Like we learned a lot of things from. So there was one instance where we went back to articles written by Walmart, articles written by Uber, on how tests should be done, how instrumentation should be done, how these should be done, and those insights, those information was very helpful for us to build our framework, to understand how we could fix the process. Initially, we were in denial that okay, it's a very big for them it is easier, but I think it's not easy for any company. So always go through what people have done, then you adapt a solution for your use case.
So learn from others' experiences.
Learn from others' experience, yes.
And then adapt it, change it for yourself, and then use it. See, but in the both the suggestions, right? Before you move on with more, can't people say, and there is a lot of time going into doing this. Like, why should I, spend so much time in solving the pattern and doing an RCA? It's just so much time investment, and reading about others' experiences, so much time investment. I could have been building a feature during that time.
So I think you used two very good terms. You use the term spend and use the term invest. I would say when you're fixing it, you're spending time, but when you're learning and then fixing it, then you're investing time.
Nice.
Because then your knowledge grows exponentially when you learn and then you do this. Because you are informed, you're taking an informed decision. When you're fixing it, you're taking an uninformed decision. You don't know why it can fail tomorrow. But having learned that information from other people, you know why it had failed for them.
Interesting. Love this analogy. That you're saying if you're fixing an instance, you're spending your time. But if you are fixing the pattern, you're investing your time, because that pattern you're preventing from happening in the future. Same goes with learning.
Yeah.
That you're investing in yourself and you're investing in your knowledge. Okay. What are the other advices? Anything on time management? Like I see you, burning your hands by wasting a lot of time in trying to fix it yourself. So what's the learning from that? Like you tried doing too much yourself.
Yeah.
And you should have figured out the responsibility much sooner.
Yeah. I think So I think that here the thing is release when you feel it is I was always in a point where I was not comfortable with the completion of the process, but I think my mistake was my benchmark should have been 70%, and then open the knowledge that I have to other people to get the feedback. So as a developer who was starting, who was probably 5 years into his career, I had this personal apprehension that, okay, other person is going to judge me for my solution, and it would be limited solution, it would be half-baked. But people should be open to feedback, open to learnings from other people. Everybody's here for a common goal, to make the product successful, make the feature successful, make the company successful. Nobody's here to fight, and there's no don't think about it. Just don't worry about it. Just focus on learning from people. I think it goes back to learning from people. If I had posted my 70% solution to other people and gotten feedback, they would have given me more insights, and I would be more comfortable just sharing it out. I didn't do that.
They would have given you a direction.
So discuss your ideas, discuss your problem with senior engineers, have people in your company, work with them, post there's always one person whom you kind of trust or or respect, or you learn, you kind of feel, okay, this guy is a good guy, I can talk to him more. Find that comfortable person, make that comfortable relationship in your company, and reach out to them. People are always are always willing to help you.
Right. So you're saying don't try too hard. If you're trying too hard to fixing something, you're probably doing it wrong.
Yeah.
Sounds good. I think it was one hell of a conversation, and thank you for unpacking journey for us, Puneet.
Thank you for having me here.
My pleasure. Catch you next time.
All right.
Sure. Bye-bye. A quick shout out to our sponsor 10xEng, who is building a product to manage all of your alerts centrally and automatically.